The programming stage, so it's already clear in the documentation stage what will happen with the system. So the programming part is the actual implementation. So this would be the concern of the IT or computer science people. What they will be doing is to implement the design expected by the user and to make it run within the system. So for example, if they will be using a web base, somehow during the design, they've decided to create a button where the user will click this one and will display something. It is expected that it will be executed consistently for all of the types of the users that require such interface. So during programming, system specification from design stage earlier are translated into software program codes. So this is meaning the programmer actually coding the system so that what the design expectation of the user will be implemented, meaning would be seen in actual system. So software may be purchased, leased, or outsourced instead. So after the design with the interaction of the user, the software development team might be decided to purchase or lease or outsource the system depending on the preference. But in the software development stage, strictly this is programming. That means if you will say you will create a website with this plugin, so we will build that system, and that's the more concern of the IT people or the technical person. So after the programming stage, you have a testing. So of course, users involvement once again would be part of this one, but we have two perspectives on testing. We have to ensure systems produces right result. We have a test plan, all preparations for series of tests, unit testing, test each unit in system separately, and system testing, test functioning of the system as a whole, and acceptance testing. Make sure system is ready to be used at the production setting. So we will reevaluate what would be the test plan. The test plan might be how the system will be tested, and sometimes this was already discussed initially during the design. At this part, test plan would be for each of the module, meaning during the system's development, it might be divided into different parts, and we can call this certain classes. We have different classes or tests. So each of these functions will be tested by some set of another developer or programmer or just users. Each of this section of the program will be tested if it's run correctly. For example, if the computation of tax is correct for payroll systems, if the salary or equivalent amount would be functioning. After that, we have unit tests. So from that different test plans on different classes, we will combine two classes, meaning one classes might access another. As my example before, if you have a payroll system and if you want to refer to the human resource data, human resource data is one class, and another payroll generation of payroll is another class. And if the payroll system want to extract data from human resource, this will be tested through a unit testing if we want to determine each of the unit of the system is working or not. Remember that the test plan is only talking about a certain class or 16 subunits, while the unit testing is a combination of different classes or units. And the system testing is testing the entire system from logging in to logging out. And so that means it's already combined as a one system, because during development it might be that the menus of the system, different menu of the system might be tested individually, and each of these menus will also be tested, and we are testing this on the testing plan. If you combine some of them, it will be unit testing, and the system testing is you test the whole system if it's functioned correctly. Sometimes a programmer might forget that if you click this button, it will link to another system, and there's a problem sometimes of this one because no one testing for the entirety of the system. So that's important. That's why system testing is important. Also, acceptance testing. This is how the user now perceive the system as a whole. So after the system testing, the user now will test. Sometimes system testing would involve testing within the developer's team, meaning within the systems development team or the people working on how the system will work. The acceptance testing now will be involved the end user, meaning if the end user is involved in the software development outside of the team, someone must test the system if it's working or not. After acceptance testing, so we will try the sample test plan to test the record change. So that means we have here a procedure is address and maintenance records change series. So we have test condition reference, so we have change record 2.1, change existing record, and we have a special requirement, key field, other fields, change deleted record, and expected result is there's already an output and if it's already working or not. So for example, not allowed meaning it's successful. A non-existent record is that it will display an invalid key message, and it change deleted record deleted message, and if make a second record okay if valid transaction file. So there is a series of tests. Example last is abort during change, abort 2.5, a specific special requirements, and no change transaction file, and there is a next screen reference which is V45, which will the programmer actually knows which of those screen is actually the V45. So the conversion process, the process of changing from old system to new system. So the conversion process would be part of after the testing part. How can we now integrate the new systems developed to the existing process of the organization? And there are 4 main strategies here presented. We have parallel strategy, direct cutover, pilot study, and phase process. We have also, and it all requires end user training and finalization of detailed documentation showing how system works from technical to end user standpoint. So meaning we are actually, let me check the part. Okay, so in the conversion process, we will define here how will the system be integrated, as I've said. So we have parallel strategy. The parallel strategy would involve implementing or running the old system while the new system is being run. So this is a very expensive conversion strategy. Here, after the testing of the system, if it works, so we are not yet confident of converting totally to the new system, so the parallel strategy is being implemented. So while running the old system, we are also implementing the old one. So that means there is a parallel system supporting the organization process, the old one and the new one. So this is also may be expensive in terms of labor, because if the user or if the old user is not yet familiar with the new one, so someone might hire another to run the old system until run the new system while the old system is running, and the time will come that the old system will be eliminated. But the initial conversion or the initial integration of the new system to the old system is running them both the old and new. The second strategy is direct cutover, which is a very risky act of the organization. The direct cutover is to directly stop the use of the old system and implement the new one. So this is risky, especially for financial, because there might be data losses, or there might be problem with the implementation, or some customers might not understand the new process being implemented. So the idea is that cutover, also this is less expensive, but sometimes not practical also, depending on the situation. But the idea of cutover is that you determine a certain date where this system will end and start the new process. So that's direct cutover. Another is pilot study. This is applicable only for systems that can be divided into modules. If you can divide the different functionalities of the system, that means if you can divide a system supporting the HR department, a system supporting the accounting department, and a system, for example, that will support the supply office. So in the pilot study, you first implement one module. For example, if you will implement it the human resource, so you implement it the human resource. While the other systems such as the accounting and the supply office are still using the old system. So you start piloting the system, the new system, in one department only. So that's the pilot study. That's why it's called pilot. And last is a phase approach. That means phase 1, almost similar with pilot study, but the intention of the phase approach might be based on the functionalities of the system. That means phase 1, we will implement this module, but it might be covered. It might cover different departments or different processes. So different phases. So phase 1, phase 2, phase 3, but it might not be considered a pilot, but they are almost the same. So So if you imagine, later we will summarize. So lastly, we have the production and maintenance. This is system reviewed to determine if any revisions needed. So meaning we are in the production area. That means we put into the system already and it's already running, and we are looking now for some improvement or critical changes or improvement. In fact, we are also evaluating here if the system is effective or not. So also may prepare formal post-implementation audit documents. So this is also determine the usage part, if it's okay or not. And maintenance, changes in hardware, software, documentation, or procedure to a production system to correct errors, meet new requirements, or improve processing efficiency. So this is while doing, and sometime maybe after 3 months to 1 year, you are already on the maintenance stage, especially if there are software updates and you need to update your system, or your hardware updates if there are new hardware for the system to be improved. So that's the maintenance stage. And in fact, 60% of maintenance works involve user enhancement, improving documentation, and recoding system components for greater processing efficiency. So that's the production and maintenance. So at this stage, after conversion process, you are already running the system and trying to identify additional improvement of the system until it will be not really applicable, but the overhaul of the system, or might be another improvement, because as we've learned, there are a lot of changes in technology every 2 years or less. So to summarize, the summary of systems development activities would start with systems analysis. As I've said, other book would describe planning stage before systems analysis, but in our discussion, we involve systems analysis. Part of the feasibility study is already on the analysis part. So a short description of this one would involve identify the problem, specify the solution, and establish information requirements. Second, we have systems design. We have create design specification of the systems. Third is programming, translate design specification into code. After programming, we need to test it, and we have unit, system, and acceptance test. And conversion would have plan conversion, prepare documentation, train users, and tactical staffs. And during production and maintenance, we operate the system, evaluate the system, and modify the system. I think that through this process, we are already looking at the systems development. That means from the conceptualization of specifying what the system can do to running the system within the organization.